Hello everyone, let's take a look at our next problem. If the trapezium rule is used to estimate the integral of f between 0 and 1 by splitting the interval from 0 to 1 into 10 intervals, 10 sub-intervals, then an overestimate of the integral is produced. It follows that the trapezium rule with 10... Okay, so there's a whole bunch of options here. I'll write them out so you can display them, but I'm not going to read every single one of them out. Interesting. Okay, so some of you, again, the terminology here is not exactly what I'm used to, so I'm assuming that the trapezium rule is what I know of as the trapezoid rule. So we have an overestimate of this integral. Well, if we look at option A, the trapezoid rule applied to 2f is exactly the same as the trapezoid rule applied to f, except you multiply all the values by 2. So that should also give an overestimate. So option A we can rule out. Same thing should happen to option B. All of the values of f, the trapezoid rule works exactly the same, except everything will be shifted down by 1. So that's not going to affect anything. So option B we rule out. We can rule out option C, because if you write down the formula and the numerical values, the first thing you have this value, you have this function f, which is shifted to the right by 1, but then you're also moving the endpoints from 1 to 2. So the numerical values will be identical for the trapezoid rule applied in option C as it would be for the original. And that leaves us with option D by process of elimination, but it's also clear by looking at what we're trying to estimate here. I'll write down the original integral. This is overestimated. In fact, what I'll do is I'll let T prime be the trapezoid rule approximation of the original integral. Okay, so this means that T prime is greater than or equal to the original integral. So T prime is the trapezoid estimation rule applied here. And if we look at the integral we're given in option D, the integral from 0 to 1 of 1 minus f of x dx, this is equal to the integral from 0 to 1 of 1 dx minus the integral from 0 to 1 of f of x dx. Well, this first term here is just equal to 1, and you'll notice that this term is just the original integral we wanted. So if I replace this with T prime, then this thing gets bigger, but because there's a minus sign in front of it, it means the entire thing actually gets smaller. But this, if you worked out exactly what the how the trapezoid rule would work, the trapezoid rule basically works linearly with respect to all these transformations of the integral. This would be the trapezoid approximation of this. Okay, and so the trapezoid approximation, let me call this thing T double prime. Where T double prime is the trapezoid approximation of the integral given in option D. The relation between this trapezoid approximation and the original trapezoid approximation, this one, is exactly this. So we see here that the integral we're now concerned with, its trapezoid approximation will be an underestimate. So it's option D, but we knew that already by the process of elimination. Yeah. What was the kind of key in this one? Well, just understanding that the trapezoid approximation kind of works. The trapezoid approximation of an integral for a fixed number of subintervals will have a lot of the same linearity properties of the actual integral. In fact, you can think of replace the function f with a piecewise linear approximation of f. The integral of that function is the trapezoid rule. And so all of the transformations that we're kind of concerned with here in the options A, B, C, and D, the trapezoid rule will sort of satisfy the intuitive properties that standard integration would for the function in the first place. So just the fact that we have a negative sign in front of f in option D, this thing here, this negative sign on the function f in the integral, just means it's going to kind of flip the behavior of the trapezoid approximation when it comes to overestimating and underestimating. Yeah, there's not much more to this question, I guess. But if I have any more comments or if I find a mistake in what I've done, I'll put them in the description below. Thanks for watching.